Okay, so we're going to take a minute and revisit question 2C. Run a one variable statistic on the height data provided from class. We did that during class. When we ran that one variable statistic, we found out that the mean, the average, x bar, is 162.2. We also found out that standard deviation, the population standard deviation, is 7.5. At this point, we go to RTI Inspire Graphing Calculator. Now, my goal was to store 162.2 as x for the mean, 7.5 as p for our population standard deviation, and then just calculate the deviations from the mean. So x plus p, that's one deviation from the mean to the right. X plus 2p is two deviations. X plus 3p is three deviations of the mean. Go to the other side, one deviation below the mean, 154.7, two deviations, 147.2, three deviations, 139.7. Now, all this data goes right into our graphic organizer right here. 139.7, 147.2, 154.7, our mean 162.2, 169.7, 177.2, and 184.7. Our goal is to look at this data and compare the heights that I measured. Now, somebody that I spoke with in class said that their height was 154. So I plotted that person in purple right here, just a little bit to the left of this deviation. My height was actually 165. So I plotted that to the right of the mean, and that's my data point right there. So the question I'm asked to answer is, describe each of us in terms of deviations from the mean. Now, notice this green arrow from the mean to this first deviation. That's one deviation from the mean. So if I'm describing their height is a little more than one standard deviation below the mean. So I think some people might have gotten caught up in, how are they going to word this? What wording do we need to use? The focus for this is to just describe the mean and where your data point is by using standard deviations to describe it. So this arrow is one standard deviation away. Since it's to the left, it's below the mean. And that describes that person with a height of 154 centimeters. And remember, our centimeters, our unit of measure for our standard deviation, is the same as the unit of measure for all our data points. We're measuring in centimeters, so everything that's happening is in centimeters. Now, when we look at this purple arrow to describe my height, this doesn't even go an entire standard deviation from the mean. So I am really close to the mean. So what I'm going to say is less than one standard deviation above the mean. Now, when we go back to our vocabulary key, we've discussed the mean. Everything we're doing here is population standard deviation because we have all the data. Remember, the samples are only for, like we did with the ticket out, where we're given information about a big pool of data and we've only got a little piece, right? But the big idea that we're adding today is these typical values. And what I want you to think about is a typical value is very similar to the mean. So something closely related to the mean is considered typical. So when we go back and look at our model, generally those typical values are within one standard deviation of the mean because they're typical of our data set. So, this one missed by a little bit. That's really, really close. But if we're way over here at 2 standard deviations or 3 standard deviations, those would not be typical values. I don't expect a lot of people to have a height less than 139 centimeters for this group. I wouldn't expect a lot of people to have more than 184 centimeters for this group. So those typical numbers are really close, usually within 1 standard deviation of the mean, right there in the middle. And that's why we use standard deviations. And the power of this lesson, what I want you to remember, is that here to create this model, we needed 2 pieces of data. We needed the mean and the standard deviation. And with those 2 pieces of data, we could actually set up this entire model to suggest where we should expect to find all those typical values. Now, the one last thing I want to remind you about is when you actually calculated the distance from your data points, the distance from the person you measured and the distance that you measured yourself, make sure I put absolute value in my calculator to get these values. ABS, absolute value, because I don't want these numbers to be negative. Remember, a distance between 2 points can never be negative because there's a distance. The smallest distance you can ever have is 0.